Hello everyone, welcome to KV Maths. Up to now we have discussed 4 parts of real numbers and today let's discuss the 5th part. In 5th part we are in 3rd question. Once read the 3rd question. Use Euclid's division lemma to show that square of any positive integer is in the form 3p, 3p plus 1. Use Euclid's division lemma to show the square of any positive integer is in the form 3p, 3p plus 1. Read the question until you understand it. Use Euclid's division lemma to show the square of any positive integer is in the form 3p, 3p plus 1. Okay. Now let's do the solution. Let a be any positive integer. Let a be any positive integer. Take b equals to 3 because in 3p 3 is a b. Okay, by Euclid's division lemma, by Euclid's division lemma, a equals to bq plus r, where 0 less than or equals to r less than b, means a equals to, here we took b as 3, so it is 3q plus r, where 0 less than or equals to r less than 3. Okay, because b equals to 3. Okay, b equals to 3. So r values are either 0 or 1 or 2 because r is less than 3 and it is equals to 0. So now let's check if r equals to 1. Sorry, if r equals to 0, then a equals to 3q plus 0, which gives 3q. So a equals to 3q. So in the question it is given like square of any positive integer. Okay, so now let's do squaring on both sides. Okay, squaring on both sides. Simply SOBS. Okay, SOBS, squaring on both sides. So a square equals to 3q whole square. 3q whole square. Okay, a square equals to 3 square is 9, q square, 9q square. So a square equals to 9q square can be written as 3 into 3q square. 3 into 3 q square, where q be any integer. Q be any integer. Then a square equals to 3 into p. Okay, I took 3q square as p because in question it is given as p. So I took 3p. It is very important. I took 3q square as p. Okay, 3q square as p. Okay, so it is 1. So now check if r equals to 1. If r equals to 1, then a equals to 3q plus 1. Again squaring on both sides. SOBS means squaring on both sides. Now a square equals to 3q plus 1 whole square. It is in the form a plus b whole square equals to 9q square plus 6q plus 1. It is in the form a plus b whole square, where a plus b whole square equals to a square plus 2ab plus b square. Simply I have wrote like this, and here a square equals to, take 3 as common from first 2. Okay, 3 take common, so you get 3q square plus 2q plus 1, where q be any integer. So take the full bracket one as p. So you get 3p plus 1. So a square equals to 3p plus 1. Take this as 2. Now let's check if r equals to 2. If r equals to 2, then a equals to 3q plus 2. Again squaring on both sides. SOBS, squaring on both sides. A square equals to 3q plus 2 whole square. Okay, a square equals to a plus b whole square. 9q square plus 12q plus 4, where q be any integer. A square equals to, now from first 2 take 3 as common. 3 into 3q square plus 4q plus and write 4 as 3 plus 1. Oh wait, I did a mistake. A square equals to, see, 9q square plus 12q plus, write 4 as 3 plus 1. Okay, a square equals to, now take 3 as common. You get 3q square plus 4q plus 1 plus 1, where q be any integer. Okay, q be any integer. Take the full bracket one as p. So a square equals to 3p plus 1. Mark it as 3. From 1 to 3, we conclude that every square of any positive number or integer, any positive integer is in the form 3p comma 3p plus 1. I'll explain this again because this is very difficult sum. Read the question. Use Euclid's division lemma to show that square of any positive integer is in the form 3p comma 3p plus 1. Let a be any positive integer and take p equals to 3. By Euclid's division lemma, a equals to bq plus r. Yesterday also I have told you this is very important. I have highlighted this. A equals to bq plus r, where 0 less than or equals to r less than b. Maximum first chapter depends on this. A equals to 3q plus r, because b equals to 3, no, where 0 less than or equals to r less than 3. So values of r is 0 or 1 or 2. So what if r equals to 0, then we get a equals to 3q plus 0, where a equals to 3q. While doing squaring on both sides, we get a square equals to 3q whole square and a square equals to 9q square. From this, on the right hand side, take 3 as common. So a square equals to 3 into 3 square, where q be any integer. Take the bracket 1 as p. So a square equals to 3p. Mark it as 1. So if r equals to 1, then a equals to 3q plus 1. While doing squaring on both sides, we get a square equals to 3q plus 1 whole square, and it is in the form of a plus b whole square. Change it into a square plus 2ab plus b square, then we get 9q square plus 6q plus 1. A square equals to, take 3 as common from first 2. So 3 into 3q square plus 2q plus 1, where q be any integer. Now make the bracket 1 as p. So we get a square equals to 3p plus 1. Mark it as 2. If r equals to 2, then a equals to 3q plus 2. While doing squaring on both sides, we get a square equals to 3q plus 2 whole square. Then a square equals to 9q square plus 12q plus 4, where q be any integer. Now chain RHS 4 as 3 plus 1. Then take 3 as common. Then a square equals to 3 into 3q square plus 4q plus 1 plus 1. Now change the bracket ones as p. Just take it as p. Then you get a square equals to 3p plus 1. In the question, it is given like, see, in the question it is given like, show that a square of any positive integer is in the form 3p and 3p plus 1. That is what we got in 1, 2 and 3. So we have concluded that. We conclude that every square of any positive integer is in the form 3p and 3p plus 1. Okay. Now let's do the next sum. Next sum is use the Euclid's division lemma to show that the cube of any positive integer is in the form 9m, 9m plus 1 or 9m plus 8. This is somewhat tougher. Not tougher actually, but it is lengthy. I'll read the question again. Use the Euclid's division lemma to show that the cube of any positive integer is in the form 9m, 9m plus 1 or 9m plus 8. Okay. Let's take A be any positive integer. Hope you know plus V means positive. A be any positive integer. And take B as 9. Because in the question it is given like it is in the form 9m, 9m plus 1 or 9m plus 8. While I am doing sums, keep the textbook beside of you. By Euclid's division lemma, A equals to BQ plus R, 0 less than or equals to R less than B. Again I am telling you, this is very important. I have highlighted this, okay? Fine. Now A equals to 9m plus R. Okay. Then R equals to 9m plus R, no? 0 less than or equals to R less than B. So here B is 9. R should be less than 9 and equals to 0. So R equals to 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. We need to check for all these values. So let's check if R equals to 0. A equals to 9m plus 0. So A equals to 9m. Cubing on both sides. Because in the question it is given like cube of any positive integer, no? So let's do cube on both sides. Cube on both sides. Simply COBS Then a cube equals to 9m whole cube. Okay, 9m whole cube. Now a cube equals to, take 9 outside, then you get 9 into 9 square cube. For q be any positive integer, then q square, then p square q cube equals to m. Let's say, okay, I'll tell you again. See, cubing on both sides, COBS gives a cube equals to 9m whole cube. A cube equals to, take 9 out from 9 cube, then it gives you 9 into 9 square cube. For q be any integer, any positive integer, then q square cube, sorry, again I wrote mistake, sorry, then p square cube equals to m. Let's say p square cube equals to m. So a cube equals to 9m. So here you have out why we took m. Okay, if you see in the question, it is given like 9m or 9m plus 1 or 9m plus 8. So I took m. Okay, let p square cube equals to m. So a cube equals to 9m. So let's check if r equals to 1, then a equals to 9q plus 1. Now cubing on both sides. COPS means cubing on both sides. Okay, in exam you have to write full, but in the video it is difficult to write everything now, so I am writing like this. A cube equals to 9q plus 1 whole cube. So a cube equals to, just apply a plus b whole cube, then you get 9q whole cube plus 3 into 9q square to 1 plus 3 into 9q into 1 plus 1q. It is a cube plus 3a square b plus 3ab square plus b cube. So a cube equals to, take 9 as common from first 3. Okay, take 9 as common. So you get 9 into 9 square cube plus 3 into 9 into q square plus 3q square, plus 3q plus 1. Did you understood this? 9 cube there, so I took 9, then it is 9 square and cube plus here 9 square is there, so I took 9 now, so it is 9 into q square plus here only 9 is there, I took it, so 9. So no 9. So just 3 square. Sorry, 3 cube. So a cube equals to, take the full bracket 1 as m. Then you get 9m plus 1. Okay. Now check if r equals to 2. Somewhat not difficulty, but it is lengthy. For r equals to 2, a equals to 9q plus 2. So cubing on both sides. Do not skip the video at anywhere. A cube equals to 9q plus 2 whole cube. A cube equals to 9q whole cube plus 3 into 9q square into 2 plus 3 into 9q to 2 square plus 2q. It is nothing but a cube plus 3a square b plus 3ab square plus b cube. That's it. It is very simple. Just write it like this and take a cube equals to, take 9 as common, then take 9 as common from first 3. Okay, now you get 9 square cube plus 27q square plus 3q, and you get 4 plus 2 plus 8. Okay, sorry, not 4, 3. Wait, and you get plus 8. Okay, 2 cube is 8. Take the full bracket 1 as m. Then you get a cube equals to 9m plus 8. You have to do this up to r equals to 8. Up to r equals to 8. So you do up to r equals to 8. Then you get every cube of positive integer is in the form 9m, 9m plus 1. So today's homework for you is fourth sum. Do fourth sum as homework, and thank you for watching. If you haven't subscribed up to now, please subscribe it. Watch the video till end, and thank you.